Good particle effects can completely transform a data pack. They can take fairly simple features and make them into something magical and spectacular. But when you're starting off, it can be pretty tempting to look at something like this and think, yeah, there's no way I could ever do that. Today, I want to try breaking down that barrier of entry and show you how you can make your own crazy particle animations. This video is going to have 3 parts. We'll have a basic breakdown of the particle command, a little walkthrough of the 2 main methods of particle effects, baked and dynamic, and then finally, we'll go right through an example of making our own particle animation from scratch. So with that out of the way, let's dive right in. Alright, so here we got Bob the command block. Bob's going to help us learn the ins and outs of the particle command. So let's just crack it open. So if we type particle, we're going to see a list of every single particle in the game here. So you can just pick any one we like. I always like flame. I think that's just a good... Actually, let's do soul fire flame. That's even cooler. And if we hit done and flick this lever, nothing's going to happen. And the reason for that is because this is just spawning a particle inside the command block. And actually, if we go in here, we can see it. So let's move that up with some coordinates. So we'll use relative coordinates. And honestly, with this tutorial, I'm going to be assuming that you have some command knowledge. I'm going to be assuming you understand how coordinates and stuff work. And if not, I'd say look to other people. CloudWolf's a great resource. And now our particle is spawning in a visible spot. So perfect. So after the coordinates, we have 1, 2, 3, 4, 5 numbers, which is a little bit overwhelming, but we're going to break down what each of these do. So these first couple numbers here, they are the delta value. So I'm just going to set this to 111 for an example. And I'm going to change this to 1 as well. I'll explain why later. But you're going to see now our particles are spawning in a little cloud. And basically what each of these numbers does, it's an XYZ coordinate that tells how far it's spread out. So if I just do like 1, 0, 0, it'll be along the x-axis. And we can see we got a little bit of a line going here. We could also do 1, 0, 1, and we'll get a little bit of a circular-ish cloud. And now the second value right here is your speed value. It tells you how fast the particle is going to move. So if we set it to 1, now all of a sudden we have some very, very fast particles. So let's tone that down a little bit. We'll set it to 0.1. Just get a little bit of motion. Yeah, I like that. And then finally, this last value here is your count. So this is basically how dense it is, how many it will spawn. So we'll do 100. And oh wow, that is a lot of particle effects. But I guess it demonstrates how it works. And this last field here, force versus normal, this basically tells you, because if I can show real quick. If I go really far away, actually not even that far away, you can't see these particles anymore. But when I get closer, they appear. So if we turn on force, this basically makes it so the particles are forced to render even when you get farther away. So this is something to consider when you're trying to optimize. Like, do I need these particles to be seen from far away? Or can I let them unrender when they're far away? Now that all seems pretty simple, but there's some hidden nuances in here too. Little tricks like, for example, if you set the count to 0, it'll, instead of using the delta value as a spread value, it'll actually use it as a speed value. So as you can see, we put in 1, 0, 1, so it's sending them in the positive x and positive z direction. And if we change this, for example, to 1, 1, 1, then it starts going up in the y value. We could change this to 1, 4, 1, and it'll go even faster. And there's actually another trick you can do here to get a dynamic direction instead of just a hard-coded one. But I have another video explaining that already, so I won't go into it here. Finally, one more thing I want to show is, let's say I try to do particle dust. You're going to see already that it doesn't like that. And we're getting this error that says can't parse particle options. So what is happening here is that some particle effects, they need you to specify some options. So I think for dust, it's scale, like 1.0f, and then I think color is the second field. Actually, let's try running it and see what error we get. So yeah, no key color, so we have to fill in a color field. And we'll just do, it's an RGB value, so we'll do 1.0f, 0.0f, 0.0f. And that'll give us red, I believe. Oh, and we're missing something else, let's see. Oh, this has to be a curly braces. There we go. So now we get a red particle effect. And something you'll notice with this is that it does not have motion like the particles did before. Some particles just do not support motion. Flame is one of the special ones that does, but a lot of them don't. And we can change the color of this, so we can make it yellow if we change this to 110, or we could change it to green by getting rid of that one right here. And if you're ever unsure what these fields are, you can probably look it up. I'm not entirely sure where. I usually will just use the debug messages or the error messages. Like, it'll tell you what you're missing. So like here it says I'm missing color, and usually you can kind of guess from there. But if someone knows a good website that like lists all these things, definitely leave it in the comments, and I can go ahead and pin that. Okay, so we got the basics down, but now the question becomes, how do we get from this to this? Now, there's two main approaches I like to use here. I'll be referring to them as baked effects and dynamic effects. And we'll go into the differences later, but let's just start by digging into baked effects. So for this tutorial, we're going to be using Bolt. And if you haven't heard of that, I'd recommend checking out my last tutorial video. I explain in detail how to set it up, how to use it, and it's going to be very, very helpful for doing these particle effects. So I have just a very basic Bolt structure set up here, just a little beat.json. You can copy this as much as you want. You can obviously change the name and stuff. But other than that, we just have some empty folders here, and this is where we're going to do all our work. So we're going to make a new file called main.bolt, and this is what we're going to be acting in. So let's make a function. We'll call it, let's see, my particle test. And let's say we want to draw a line. So maybe we want to do it in the direction the player's looking. So we'll do particle flame 1 block ahead. And maybe we'll put one 2 blocks ahead. And 3 and 4 and 5. So if we go ahead and do beat build. Oh, we got to sync this up to our world. Tutorial world. So we'll do beat link tutorial world. Okay, now it's linked up to our world, so if we beat build again, the Datapack should be in our world. Oh, we need to put this in a modules folder. So we'll throw this in here. Now let's try it. Yep, okay, so we get an output Datapack. And if we reload in this, we should see now that there is, yep, our functions in the game, and it draws a line of particles in the direction we're looking. Now let's say we want our line to be a little bit thicker, so maybe we'll do like 1.5, 2.5, 3.5, etc. Just because we want more particles in there. So we'll build that back up. And yeah, there we go. We got a line of particles. So that's pretty nice. But there's something kind of annoying here. This isn't very extensible. We have to write out by hand a bunch of different individual particle commands. If only there was some way that we could... Oh wait, we're using Bolt. So what Bolt lets us do is we can do for I in range, let's just say like 100. We'll do particle flame, and actually let's make we'll just say x equals I divided by 10. Particle flame, boom boom, and we'll use our variable x. Now, if we try running our function, we get a nice thick particle command, and just to see what that output in the output data pack, so if we look, this actually made a big list of particle commands on the fly for us. So it's like whoop-de-doo, we got a line of particles, so what? But there's more that we can do here than just lines. Let's say we wanted our line to be wavy. Well, we can do, let's just say z, actually I'm getting these coordinates, we'll say waviness equals, we'll do, actually let's import a math library. So import math, and then we'll say math.sine of I. We'll say just divided by 20. And actually we'll multiply that by 5 just to make it really wavy. And we'll use waviness for our left to right value. Now if we run our function, ooh, it's nice and wavy. That was a lot more wavy than I was expecting. Let's try upping the frequency on that. So instead of dividing this by 20, we'll divide it by 4. Oh, that is a lot more wavy than I was expecting. I think I actually like the 20 better, but let's decrease the amplitude and make this go a little bit further. Let's just make it 1,000. Ooh, I like that. So we just got a sine wave in Minecraft, and it's not computing any sine waves in game. It's all pre-generated. So that's why I call this baked particle effects, because you're creating all the entire, like you're creating the whole effect, computing it before you actually load it into the game. Now just another quick example. Let's try doing a circle. So we'll do function myParticle circle. And so the question becomes, how do we draw a circle? Well, if you are familiar with any trig stuff, you know you can make a circle by just increasing sine and cosine and looping through a bunch of points on it. So we'll do another for I in range. Let's just say 100 again. And we'll say that our angle will be 100 divided by 2 times math.pi. So that's turning this into radians. Getting it to go from, oh wait, am I doing this right? No, I'm doing this wrong. It should be 2 pi divided by 100. So what this will do is it'll make it sweep over all angles in the range. And we'll say that the x coordinate of that circle is math.sine of angle. And we'll just make a radius variable real quick as well. We'll say radius equals 5. So 5 times math.sine of angle. And then we'll say z equals 5 times math.cosine of angle. And then we'll just plop down a particle effect using those coordinates. So we'll say x, z, and let's do end rod. End rod is one of my favorite ones. It's just a very pretty particle. I definitely use it way too much. But if we, oh, and we got an error. Oh, because end rod goes first. Oopsie daisies. Okay, now, actually, let's have Bob run this command. Function myParticle circle. Oh, it's not working. Let's see why it's not working. Oh, because we're not multiplying by I. Now, should see, Bob has made us a circle. Look at that. So I hope you guys are starting to see here that really the only limit is actually your mathematical knowledge. And you don't have to be a math genius. As long as you can figure out some very simple things, you can do a lot of cool stuff with it. I'd say sine and cosine are your best friend in the world. If you just throw them wherever, something cool is going to happen. But yeah, now Bob's got like a little protective force field or something. I don't know. Bob's doing Bob things. We'll shut it off. So I know you're thinking, this is great and all, but how do we get some of those animations? So that's what we're going to dive into next. And there's a little bit of setup here. So we got to add some sort of scoreboard that we can use. So we'll just, actually we'll say append function tag Minecraft load. And we'll just add in a little load function here. myParticle load. And we'll create that function, myParticle load. And we'll just add a scoreboard. And we'll just call it timer. So let's make sure our scoreboard's in the game. So if we use a scoreboard objectives list, yep, we got timer in the game. So we can start using that for our commands. So we're going to start really simple here with just like the most basic principles of making an animation. And I'm going to be doing this in a slightly inefficient way. You could technically optimize this more by using like scoreboard trees and stuff, but honestly the gains and performance are going to be so minimal in most cases that I don't want to overcomplicate the tutorial. So how do we do an animation? Like no bolt stuff involved, just like simple stuff. Let's say we'll scoreboard objective or players add, and we'll just use a fake player. We'll call him Ticker, and we'll just add 1. Now, the idea behind this is that we'd say, like maybe we just want a particle to move along a line. We'll go back to lines. We're good at drawing lines. So we'll say if score hashtag ticker timer matches 1, then we'll draw a particle, run particle flame just in this spot. Oh, and also this is a bolt thing right here, being able to say if instead of execute if. I'll do the whole thing just for the sake of simplicity. And then we want to have the next tick that we draw it somewhere else. So we'll say if it matches 2, we'll draw it, let's say 1 block in the X direction. And then 3, we could do 2 blocks in the X direction, and so on and so forth. And then we want this animation to loop, so we'll just say if score hashtag ticker timer matches 5, then, oh, I'm doing the thing again. Execute if score ticker matches 5. Run scoreboard players set ticker, and we'll set it to 0. So this should cause it to loop, but let's have Bob run it and see if it works. So we'll go over to Bob, and we'll have him run our animation command. And yeah, I guess it's going a little bit too fast to see. What's a better particle we could use that's going to die? We'll use the crit particle. So I'm just going to change this to crit. We'll rebuild. There we go. So you can kind of see it's a little bit too fast for the eyes to see. But it's kind of going from left to right, following this pattern. And all we're doing is we're just adding a score and we're checking for each individual spot. So like if you're on frame 1, draw frame 1. If you're on frame 2, draw frame 2. And this is the basic idea behind making animations. Now, like I said before, there's more efficient ways to do this with scoreboard trees and such, but you're probably not going to be hurting for performance if you use this, unless you have like a billion frames. So let's go back to our circle. Let's see if we can animate this thing. And actually, I want to have this tied to the entity that's running it. So instead of using a fake player, let's actually have it use @s. So we'll say scoreboard players add @s timer 1. Now what we're going to do is we're actually going to wrap this whole thing in another loop. So we'll say for t for time in range. Actually, let's use frame. That's a bit more clear. For frame in range, we'll just have this be like a 40 tick animation. Now we can make this vary with time. So for example, we could have the radius expand. Let's just keep it simple and try that real quick. And I'll just do 0.5 times t. And we got to wrap this all in. So like before, we have to check which frame it is. So we'll say execute if score @s timer matches. And we're going to use frame. So this is the variable, the same variable as before. We're using that to check against. So when this compiles, whatever value frame is, it's going to get checked against that value. And we'll just indent all of this. So we're going to compile this, and I want to show you all just what it generates, just so you can get an idea. Oh, we got an error. What did we do? Oh, I used t instead of frame. Now let's see what this actually outputs. So if we go into our circle function, and it's always checking 0 for some reason. Oh, okay, so this is a little trick here. So instead of checking a bajillion particle commands, we want to actually have this, because this is basically for every single particle, it's saying execute if score. We don't want to do that. Let's move this above here, and then we'll indent this. So now it's saying execute if score, and then it's generating the whole set of particles. So we'll see. Yeah, okay. So now it's checking through every frame, all 40 frames. And it says execute if score timer matches 0. Then it runs this. It goes through this nested execute command, and Bolt just auto generates these. It's very nice. But if we go to nested execute 0, we can see it's just a bunch of end-rod particles. And there's actually one more thing we need to add to this. We need to add that looping behavior. So making it hit 0 after it hits 40. So do execute if score @s timer matches 40, then and scoreboard players set @s timer 0. There we go. Okay, and now we want this to run as the player, so we're gonna do execute as @p @s run function, and we're gonna run our circle function. So do my particle circle, and now it doesn't seem to be increasing. I swear I'm not actually doing these as like teaching examples. I'm just legitimately bad at coding. What do we do wrong? Oh, I'm using 5 instead of the radius variable we coded. Okay, now let's just see this thing animate. Oh, look at that. We got a little pulse action going on. So yeah, we just made a animated like pulse circle thing. Now something I want to emphasize too is that position isn't the only thing you can have vary with time. For example, let's say instead of changing the radius, oops, we'll just say radius equals 3. Let's try using that dust particle from earlier. So we'll say scale 1.0f and color. We will do. How about we let's define a separate variable here, and we'll say glowiness. And we'll have this glowiness variable vary per frame. So we'll say it's frame times, and let's make it bounce with a sine wave. So math.sine. And we'll do the frame times, well, we have 40 frames, so we want to make it do 1 cycle in 40 frames. So that'll be times 2 times math.pi divided by 40. And if you're wondering where I got that math from, it's just 2 pi would be 1 cycle, and then we divide it by 40 ticks. And then we just kind of increment through the frames, the 40 frames. So now if we do our glowiness factor here, and then 0, and then 0, it should automatically substitute that in, but let's try and see. No, we got an error. Oh, I did the same thing as before. There we go. And also, I don't know why I'm multiplying this by frame. There we go. And actually, since this is a sine wave, let's add 0.5 and then multiply it by 0.5. So it's bouncing between 0 and 1. Let's see if this works. My one concern is that these aren't formatted as floats, but we'll see. Oh, there we go. So the color is changing. It's bouncing with a sine wave. And you can see it's kind of having this pulsating effect. And just as one more quick little thing, just so I can show you guys like the incremental nature of designing these particle effects, I'm going to add a Y value, and we're going to make this one actually dependent on its angle. We'll say 0.25 plus 0.125, so 1/4 plus 1/8 times another sine wave, and we'll just do the angle times, I don't know, 10. Let's see how that works. And I just want to emphasize that, like, I'm totally just coming up with this stuff on the fly. Like, you can do whatever the heck you want, and that's really the fun of this. Oh, I didn't actually use Y. Now, let's try it. So yeah, now we get a little waviness to it. Oh, isn't that cool? I love that. And of course, you could keep going. I'm honestly feeling tempted to right now, but we got to move on. But like, you could make this spin. You could make the height of this, the amplitude of this vary with time. Actually, wait. Oh, baby. Oh, that is so sick. So this is the fun. Wait. Let's see with shaders. Oh yeah, shaders automatically make any particle effect look better. That's rule number 1 of particling. So as you guys can see, I have a lot of fun with this. And you could always keep going. There's always more you could do, but a lot of it is just spam sine waves everywhere. So that was baked particle effects, but I also mentioned another kind. So what we're going to be getting into now is what I call dynamic particle effects. And the idea behind this is that, say you're wanting to draw a line, for example, from Bob to me. The distance between me and Bob is going to affect how many particles you draw. And with baked particle effects, it's preset at like the time that the code is compiled. It's not going to change. It's not going to vary at all. And sometimes you need your effects to react to certain features in the game or certain conditions. So basically the principle behind dynamic effects is that instead of pre-generating every single particle command, you're using Minecraft commands as a source of logic to determine where to place those particles. So we're going to start off with a classic example of just doing a raycast. Drawing a line from Bob to me. So we'll do function my particle line to me. And we'll do execute facing at P to start off. And we'll do a flame particle. And actually, let's define a separate function. So we'll say, oh, and I think we have to add eyes here for this to work. And then we'll do function my particle raycast. And now we'll define that function. And inside this, we'll say particle flame. And if you're unfamiliar with a raycast, the idea is that you just call the function inside itself, but at a different position. So it infinitely loops until you hit some sort of stop condition. So we'll say function my particle raycast. So the function is going to call itself, except we want it to move forward. So we'll say execute positioned. We'll just do like 0.3. And we also want to have some sort of stop condition. So in this case, we'll just say if there's a player nearby. So we'll do if entity at a distance equals 2. This is obviously not the most efficient way of doing this, but I want this tutorial to be reasonable length. Oh, we have to add entity. Now let's have Bob run this function. So say function my particle line to me. And we flick it on. It doesn't work. Oh, it's because this should be unless. We want it to keep going forward unless it hits a player. And there we go. Now Bob is drawing a line towards my eyes. And as you can see, it adjusts in length. And yeah, no matter how far away I am. So there's only one particle command. So like as you could see with the previous ones, it was generating like thousands of particle commands, whereas this is a singular particle command wrapped in some logic. Now there's one other feature of dynamic particles that I want to showcase, because honestly you can't have a comprehensive tutorial on this. It's a lot of just knowing Minecraft commands and being able to think outside the box. But another big thing you can use is macros. Let's just, as an example here, we're going to add a new scoreboard, and we're just going to call it excitement. It tracks how excited you are, and players can just tell the game, I'm very excited right now, or I'm not very excited right now. And what we're going to do is inside this function, we're going to store that value into a storage. So we'll say execute store result storage, my particle, we'll just say temp, and excitement. And we'll store that. We'll scale it down a little bit, like 0.1 or 0.1. And I think we got to put int here. And we're going to get the player's excitement value. So we'll say run scoreboard, players get at p excitement. And then what we're going to do is we're going to use a macro. So we're going to say with storage my particle temp. And this is using a bolt feature right here. This isn't something you can do in normal Minecraft commands, but it's just a shorthand syntax for it automatically generates a function with a macro. And we're going to do particle flame, and we're going to change its speed value to use that excitement value we have stored. And just going to spawn one particle. We'll do force. So now our particle effect is going to be the exact same, but let's say I start getting excited for some reason. I don't know. The new Minecraft update just came out, and there's the happy gas, and I'm just really excited. So I'm gonna set this to 10. Okay, not much of a change. 100? Oh, 100 is a very big change. Let's see, 50. Oh, I think we're rounding down. Let's just change this to a float instead of an int real quick. So yeah, now I can set it to 10. I'm getting a little bit excited. Maybe I'm not that excited. I can set it to 1. And you can see they're moving a little bit, but if I set it to like 50, all of a sudden the particles are flying everywhere. So what's happening is the macro, it's causing the speed value to change based on that score. And this is obviously a pretty dumb example, but you could use this sort of thing for a lot of very cool things. Now, one word of caution that I'll give is that macros are very expensive. In this case, it's not too bad because it's using something called caching, where every single particle call is the exact same, so it just remembers. But if it's a different one every single time, it'll have to basically parse the entire command dynamically. Okay, so now that we've gone over the basics, I want to try running through a practical example of just like actually applying these things. So as you can see by the date here, we are just after 4th of July here in USA, our Independence Day. And two things I love about 4th of July are poppets and fireflies. So I had the idea, what if we made a little creation where it's like poppets, but we got this magic bag, and we can throw it here and we can fill it up by punching a firefly bush. And what I'm thinking we're going to do is this is a magic bag, of course. And when we catch fireflies in it, it's going to enchant them and make them all glowy and stuff. And instead we're going to replace this flame particle here with a cooler particle. Some sort of like little like glimmering light show of sorts. So I've already kind of made a skeleton of a data pack here. I'm not going to go through how all of it works. It's not really necessary for the particle tutorial. But I'll post the code if you ever want to look through it. But really what we're concerned about here is our projectile hit function right here. So right now we're just doing particle flame, but we're going to try to make this do some cooler stuff. And actually, we can start out by putting a flash particle in this. Let's see what that looks like. Okay, so we get a little flash here. Might leave that in. So what I have in mind is I'm thinking of doing this sort of like magical looking like lattice of like kind of like colored lights and stuff going between the fireflies. So what I want to start with doing is just making a line between two particles. We're good at that. We've done that already. So let's do that again. So we'll do function. I'm using GP as the namespace here for glimmering pouch is the name of the item. And we'll say GP draw line. And how we're going to make this work is it's going to draw a line from the executing context to the executing entity. So we're going to do like a purple dust particle. And then we'll just make this recursive real quick. Okay, I believe this should roughly draw a line. Oh, and okay. Oh, it's going off for infinity. Oh, we need to check for a range of distances here. And yeah, there we go. Now, I think what we're going to do is we're going to use a bunch of markers to basically draw lines between. I'll try 10 markers to start out with. Okay, so we're summoning marker, and then we're going to run a setup function on it. So I think we want these markers to have a random starting rotation. So what we'll do is we'll do execute store results entity at s rotation 0. So that's its x rotation, 0.001. And since we're scaling down by 1,000, we'll have to do between 0 and 3,000, or I guess 360 times 1,000. Okay, and then it just picks a random value, and then it's storing that in its rotation. That's its x rotation. Then we'll do its y rotation as well. And I think we want to limit this one to be facing upwards because it's going to hit on the ground. So I think we'll do between negative 9,000, or 90,000, and 1,000, 10,000. So between 10 and 90, negative 10 and negative 90 degrees. And I guess for now, let's just have each marker teleport itself one block in the direction it's looking to see if they actually get moved. Also, let's add a ticking function for these markers. And we'll just give these a tag of like magic firefly. And we'll say firefly tick. So we'll make this firefly tick function. And for now, we'll just have them do a particle like electric spark. Okay, let's see if this worked. Oh no, it did. We forgot to give them our tag. So in this function, we also got to tag it. Got magic firefly. Okay. Okay, yeah. So we got a random spread. Right, for now, before we give them any fancy movement, let's just have them spread out a little bit more. And let's try drawing some lines between them. So I think what we'll do is we'll do execute positioned as at e type equals marker tag equals gp.magicfirefly, and we'll limit it to 3 and pick the 3 nearest. So we're doing it at these entities but not as them, just at their position. Oh, and we'll do facing entity at s feet. Actually, let's add this in the draw line function. Let's make our draw line function a little bit more usable. We're gonna have it call a different function called gp drawLine recursive execute facing entity at s feet. So that way we don't have to add that every single time we call this. The function just handles it for us. Then we'll just package this stuff in a separate function. Then in our firefly tick, we can just run function gp drawLine. So now every single firefly should draw a line to the 3 nearest fireflies. Oh, I accidentally left a colon here. Okay, let's see if it worked. Oh, okay. That's very nice. Now something I don't like is that it's doubling up on lines. And you could have like this firefly drawing to this firefly and then this one drawing back to this one. So let's add some logic there to prevent that from happening. So what we're going to do is we're just going to add an extra tag for ones that have already drawn lines. And we're going to make it so they don't draw to ones that have already drawn lines. And then every tick we'll just refresh that tag. So right before we call it, we'll just say tag at e type equals marker drawn line gp.drawn line. So that should help get a bit more spread as well. Yeah, okay. I'm liking this structure here. Ooh, baby. Okay, and they kind of chain together. I like that behavior. I like that a lot. And actually, I'm going to change these into some constants we can tweak. So we'll say connection density here. And we'll define a variable called connection density. So we had that at 3. And then I also want to say firefly count. So this just makes it easier to tweak things. We'll just put these at the very top of the file. So we'll say firefly count equals 10 and connection density equals 3. So then, you know, if we want to make it like, we want to go crazy and say 50, then maybe change this to 2. Let's just see what that does real quick. Okay, so yeah. Oh, it's like a constellation. That's kind of cool. Okay, now let's make our fireflies move. Just for the sake of organization here, I'm going to separate this into a separate function. So we'll say firefly move tick. And also, I want to make it so these things don't last forever. So we'll add a new scoreboard real quick. I have a load function set up here. And we'll just say gp.lifetime. And we'll make it so these things die after, let's say like 5 seconds. Actually, let's make their lifetime random. So we'll have it so each firefly lasts between like 4 and 6 seconds. So we'll take a random value between 80 and 120. And for now, they're already facing like different directions. So let's just try having them move in a straight line slowly. We'll do like 0.05. And actually, let's have them start closer together too. We'll get rid of this initial teleport. Okay, let's see how that looks. Ooh, okay. It's already kind of neat. Oh, and we forgot to make them die. Wait, so we need to have this happen on initialization. So in the setup, and then we remove it. And then we say, if that score reaches 0, then it kills itself. Okay, so let's try making this movement a little more interesting now. I think I want them to have like an initial burst outwards, and then they kind of like swarm around a little bit. So let's think about a good way of doing that. I think, I was thinking about doing some like complex like vector math and stuff, but I think our best way of doing this is just hard coding in some frames and just giving a little animation curve to that like outward burst. So I'm gonna add another scoreboard here. Then we'll add 1 to that frame every single tick. Okay, so the idea here is we're gonna do something like if score gp.frame matches 1, then we'll have a big movement, like moving 1 block out. And then if it goes to 2, then we only move like 0.8, for example. But we're using bolt, so I want to try giving this a little bit of a mathematical description. So we'll say for I in range 10. We'll do first 10 ticks. And actually, we'll say frame in range 10. Then we'll make a speed variable. And let's think about what kind of animation curve we want. We want it to start out moving fast, and then we want it to slow down. So actually, I'm going to take out old reliable here. We're going to get Desmos. So let's try something simple first. We'll say y equals -x plus 10. So this will cause it to fall off linearly. By tick 10, it'll be slowed down entirely. Although we don't want it moving 10 blocks in the first tick. So we'll maybe make this x divided by 10. Or actually, just divide this whole thing by 10. There we go. So it starts out moving 1 block, and then it goes down to 0. Negative frame times 10, or plus 10. We divide the whole thing by 10. And we'll move forward by speed. Oh, we also got to make this frame. So let's see how this works. Ooh, okay. That's a good start already. I like that a lot, actually. I think I want to have a bit sharper of a curve, though. So how about we try like a logarithmic or exponential curve? Okay, I'm just going to try this one and see what happens. So we'll need to import math here. And we'll do 2 times math.exponent of negative frame divided by 5, I think was our equation. And I'm going to actually make this in a range of 15 instead. Okay, let's see. Ooh, that's pretty nice. I think I want it to be a bit snappier though, so I'm going to make this divided by 3 instead of by 5. Let's see how that looks. Ooh, yeah, I think that's the winner right there. Something I'm going to tag along here is I'm also going to add a distance check so you don't have things chaining like halfway across the world. So we'll just make sure it only chains to Fireflies that are in a range of like 15 blocks. Oh, and I just had another random idea. So they're not all on the exact same animation curve. I think I'm going to give them a different starting value for their frame. Execute store result score at sgp.lifetime. Run random value. Or wait, I want this to be gp.frame. I think I'm going to make it so they can start as low as -2 for their frame. So they get a little bit of a delay. And then start as late as 1. Okay, let's see if that delay did anything. Not super noticeable. I'm going to try increasing the range of allowed negative values. Yeah, okay, I think that adds a little bit of variety. Okay, so let's try to get some random movement. So what I'm thinking is we're going to do horizontal and vertical things separately. So we're going to get a horizontal like orbit sort of motion. So we're going to have a random like angular velocity, or I guess orbit velocity. So let's store that directly into the marker. And it's a data field. And we'll just call it orbit velocity. And we'll store that as a float. We'll scale it down by 1,000. We'll get a random value between, let's just say 5,000 and 15,000. So between 5 and 15 degrees per tick. And now we're going to do every frame past 10. So it's not doing as much orbiting when it's first like bursting out, but we'll do rotated. So that's a flat rotation right there. Basically takes away the vertical component. And we're going to use a macro here with entity at s data. So we're using the data field of the entity for this macro. We're going to rotate at s, and we're going to rotate it by this orbital velocity. And we'll have it gradually move forward a little bit. So let's see how that looks. Getting a little bit of horizontal rotation there. Okay, that's a start. Obviously very flat looking. But it already looks like the flies are starting to kind of swarm around. And actually, while we're at it, let's make this value that it like moves also random. So we'll make this another macro. And we'll call this speed. And we'll basically just copy this line right here. And we'll make this a value between, let's do like between 50 and 150. Okay, yeah. So now they should all orbit at random speeds as well. Okay, yeah, so we got a bit more random motion going on here. Let's add a vertical component to this. So let's just comment our code here real quick. So horizontal motion, and now we'll add a section for vertical motion. So the idea here is we're gonna hard code 20 frames of this bobbing animation, and we're gonna have them all start at different offsets. So we'll add another scoreboard. Let's call it Bob. And we'll do 4 frame in range 20. And actually, let's increment the Bob score. So let's just get an angle variable real quick. We'll say frame times 2 times math.pi divided by 20. So that should be a 1 full cycle done in 20 frames. And actually, before we get any random offsets, let's just do all the same offset to see if it works. We'll say bobbiness equals sine of angle. And we'll teleport it vertically by our bobbiness amount. Oh, this should be player's add. Oh, and before we run this, we also got to reset the scoreboard. Actually, and then we got to make sure this only calls on the frame it's supposed to be. So if score at s bob matches frame, our frame variable, only then does it teleport at that specific frame. And then of course we got to reset the loop when it hits 20. Actually, I'll move this down here as well. Okay, they are indeed bobbing. A little bit much. Also, something I'm going to add is at s right here, so it doesn't overwrite the previous teleport. And we'll put it here as well. Okay, so let's try lowering our bobbiness a little bit. We'll just multiply it by like 0.1. That's a start. Of course, they're all moving in sync, which is a little bit weird. Now, I actually think this is a bit too fast of bobbing. I'm going to make it 40 and 40. When we spawn the Firefly, we're going to start it on a random frame. So we'll store it in gp.bob. And we'll just pick a random number between 0 and 40. Oh, baby. That is already looking very nice. Wow, I'm a very big fan of this already. There we go. Oh, look at that. Isn't that beautiful? Okay, so there's one more thing I want to modify, and that is this function right here. Right now, we're just having a static color. I think it would be fun if we gave some sort of gradient to this. So what I'm thinking is if we make it so the closer you are to like either end, you get closer to like some brighter color. I think we could get a pretty cool effect there. So let's see what we can do. I think first order of business is determining how far we are from either end. So let's try to make a scoreboard to track that. We'll just make a fake player called distance. We'll set it to 0 to start off, and we'll just add 1 every single step it takes. So we can use this distance value to know how far it is from the first end, but we need to know how far it is from the second end as well. So this is a bit of a janky solution, but I'm thinking what we do here is we do for I in range. So what I'm thinking is like something along the lines of like if we did, you know, if entity at s distance equals 0.05 or maybe 0.2, then we'd add 2. And then if we did like 0.0 or 0.4, then we'd add 2 again. That sort of thing, like so on and so forth. Although actually we'd want to subtract the distance, I think. So yeah, we'll make another variable called other distance. We'll set it to 20. We'll do if entity at s distance equals, and we'll do I times 0.2. So we'll just make another variable. We'll call it d equals I times 0.2. So if distance is less than d, then we'll remove I times 2. So we'll say rem equals I times 2. And then we'll do scoreboard players remove other distance, then rem. And then we just want to take the minimum of those two distances. So say if score hashtag other distance Oh, and also we gotta add GP here. Is less than distance. We'll set distance to the other distance. And just to test this, we'll check if distance is less than 10, and then just throw some flame particles there. No. Okay, it took a little bit of tweaking to the code, but I did get distance detection, I believe. And yeah, there was just some bugs I made. Mostly this needs to be recursive rather than I was calling this function on accident. So now we're able to detect where the ends are. So we want to use that distance value. Okay, so what we're going to do to help us write this is we're actually going to make a Python function to pick the color for us. So we'll just call it pick color, and we'll have a start color, an end color, and then a frame. Or I guess we'll say a distance. So we want it so when the distance is very low, it's close to the start, and then when the distance is very high, it's close to the end. And distance is actually going to range between 0 and 20. So we're going to code it for that. Let's extract out some variables here. So we'll say R1 is the first element in start, because these are going to be like tuples of 3 or lists of 3. G1 equals start 1, and we'll do so on and so forth. We'll do the same for the end. We'll say R3 equals R1 plus, so we're going to do something called linear interpolation here. So let's see if I remember the equation. So we'll do R1 times distance. Actually, we'll do 20 minus distance. So that way at 0, it's multiplied by 20. And then we'll do plus R2 times distance. So then at 0, it's at 0. And we'll divide the whole thing by 20. And then we'll just do the same thing for the green and blue channels. And then boom, we'll just output this new color. R3, G3, and B3. So now we'll make another for loop for all these dust particles, for all the different colors. And we'll do for all 20 possible distances that we'll hard code. And then we got to match up the distance. So if score hashtag, I made a variable called real dist, just because it has to pick between the two distances. So I'm just using this as a kind of determiner. So it matches D, which is our loop variable. And now for each of these, let's grab a color. So color equals pick color. Let's try to find 2 RGB values we like real quick. So I'm thinking we want to go from like a midnight purple to like a much lighter purple. So something like this. Our first color is going to be this, except we got to divide each of these by 255 because the website we use gives them in 255 and Minecraft uses 0 to 1. And then I want it to go to a much lighter purple, I think. So we'll give it a little bit more red, and then I'm thinking like a very pale. Actually, maybe a bit more bluish. Yeah, I think I like that. Let's try it. And actually, I want this to be the start color. We'll do the same thing of dividing it by 255. And finally, we will pass in D. So now we need to actually pass in these colors. So we'll say color 0, 1, and 2. So let's see if this actually compiles. Okay, that's a promising start. And let's take a look at the output code real quick. Okay, so we can see it here. It's got a different color for every single distance value, so that's promising. Let's see what it does. Oh, baby. I was not expecting it to look that good. Holy crap. Oh my gosh. Wait, we gotta see this with shaders. Oh my goodness. Wait, let's make it night. Oh, baby. Oh, so we get gaps in the middle of the thing. Oh, one quick bug. I'm realizing we only go from 0 to 19 instead of 0 to 21 in these values, so you see gaps in the middle. Always got to watch out for off by 1 errors. So we change this to 21. It should get rid of those gaps. Yeah, there we go. Much better. I'm actually going to make the base color a little bit brighter. Oh, yeah, that's a bit better. Oh, baby. That is gorgeous. Oh my gosh. Well, folks, I think that's about it for this video. I hope you enjoyed. I know it was a little bit scatterbrained and all over the place. I hope you're still able to get something out of this. And I always want to emphasize that there is so much more room you can keep going. Like, even with this, I had ideas for, like, making it so the colors would be dynamic. Like, you could fill up the bag with different flowers. And you could totally do that. In fact, I challenge you to try doing that to test your skills. To make this more dynamic. Like, use the macros for the colors or something like that. But this video is already too long, so I gotta leave it here. But hopefully in the future, I want to do item display tutorials next, because you can get very cool VFX using those. I'd say even better than you can with particles. So as always, if you made something cool, like using this tutorial, feel free to share it with me. In fact, please do. I'll just put the link to the Discord down in the description. And yeah, thank you for watching. I hope it was useful for you. And, well, have a good day. See ya.